Let's solve a problem on series and parallel resistors. Here we have got 4 resistors that are connected to a 12 volt battery as shown in the diagram. In this circuit, R1 is 3 ohms, so let's just write that here. R1 is 3 ohm, R2 is not given to us, R3 and R4, they are equal to each other. The reading on the voltmeter is 8 volt. This is our voltmeter, which is 8 volt. And the reading on the ammeter is 2 ampere. So the first part is asking you what is the voltage across R3. So few things which we need to know, that R1 and R2, they are in parallel connection. So the voltage of R1 will be equal to the voltage of R2. So let's just write down that. Voltage across R1 will be equal to voltage across R2, because R1 and R2, they are connected in parallel. So if R1 is 8 volt, then R2 should also be 8 volt. That means both of them will get 8 volt each. Okay. Now similarly, R3 and R4, they are also connected in parallel. So voltage across R3 will be equal to voltage across R4, because R3 and R4, they are also connected in parallel. Now the total battery voltage is 24 volt, out of which 8 volt is going to the first set of resistors, which is R1 and R2, and the remaining, so 24 minus 8, which will be equal to 16 volt, will go to R3 and R4. So R3 will also get 16 volt and R4 will also get 16 volt, because they are connected in parallel. Okay, so the first part, which is asking you what is the voltage across R3, our answer, voltage across R3 will be equal to 16 volt. Next is asking you what is the current in R2. What's the current in R2? So let's check the diagram. We want to find what's the current in R2. Let me just highlight it. Okay, so we can find what's the current in R1, because we know what's the voltage for R1 and what's the resistance value for R1. Okay, but R2, the resistance is not given to us, so we need to figure out on some way to find out what's the current for R2. Okay, because as long as R2 is missing, we cannot find out the equivalent resistance for the circuit as well. So we will now look at the second part of the circuit, which is R3 and R4. They have given us what's the current for R4. It's given R4 is 2 ampere. Because the ammeter is connected in the R4 branch, we can see that the current in R4 is 2 ampere. And they also said that R3 and R4, they are equal to each other. That means the current in R3 will also be 2 ampere. Okay, so that means the total current is equal to 2 plus 2. So if we imagine the current starts flowing from the 24 volt battery, it reaches the first junction, it will split into 2 parts, then again come to the second junction like this, it will join, again it will split into 2 parts, again it will come back and join together. So 2 ampere from R3 and 2 ampere from R4, the total current which will come back is 4 ampere. So now we know what's the total current. So how do we write this? So the total current is equal to 4 ampere. So that's the 4 ampere current which will be reaching from the battery to this junction here. So now we know the total current is 4 ampere. So the current in R1 plus current in R2 should be equal to 4 ampere. Now we can find what's the current in R1, because we have the voltage value and we have the resistance value. So current in R1, I'm going to write it here, which is equal to voltage over R1. Voltage is 8, R1 is 3, and that should give us 8 over 3, which is equal to 2.66, and it keeps repeating, so we'll write it as 2.7 ampere. So that I'm going to put it here in this equation because I've got the current in R1, so 2.7 plus I current in R2 is equal to 4, which is the total current. So current in R2 will be 4 minus 2.7, and 4 minus 2.7 will give me 1.3 ampere. So let me just write that properly. That's equal to 1.3 ampere. So this is having lots of steps. So we need to understand we are applying Kirchhoffs current rule, junction rule, to know that the total current is being added from each branch. That means the current in each branch we are adding up to get the total current. So what did we do here? We figured out the current in R3, because R3 and R4 they are equal to each other, so their currents will be same. They already gave us what's the current in R4, which is 2 ampere, so the current in R3 will also be 2 ampere. So 2 ampere and 2 ampere will join together to give us the total current, which is 4 ampere. So that's the same 4 ampere current which is reaching this junction, which is going to split into two parts. So we are going to get 8 over 3 here, which is the V over R. So the current in R1 we can find, which is 2.7. So the current in R2 will be the remaining current, which is 4 minus 2.7, which is 1.3 ampere. Next it's asking us what's the value of resistance R4. So we want to find what's the value of R4. So we don't know the values for R3 and R4. How do we find the value for R4? Now you have what's the voltage across R4, you have the current across R4, so that's easy. Let's just write down that V equal IR. I'll arrange the formula for R, which is equal to V over I. The voltage across R4 is 16, the current is 2, so answer for the resistance 16 over 2 will come out as 8, and the unit is ohms, 8 ohms. That's how we can complete part C. Let me check if there is another part. No. So that's about this question.